So, okay, it's 12:30. I think we can right now start with our panel 9. Also, my colleague Eva, my co-panel leader, has also joined our meeting. And yeah, so let's start because we have a rather quite tight schedule for today. And yeah, welcome especially to panel 9, which is on appliances, ICT, and respective technologies and topics. And with the first panel today, with panel 9.1, heating and cooling, we asked the question, is there solutions that should be the new normal in the context of energy efficiency? And we are very happy to have several very interesting presentations here. And the first one will be given by Andrea Roschetti. And Andrea is an industrial engineering expert from Politecnico di Milano. And since 2000, he is involved in several research activity, especially in the context of energy efficiency technologies, and for analyzing respective programs, the economics, and the policies on end-use energy efficiency research group there. Yeah, then I would hand over to the presentation of Andrea. And remember, because we have recorded sessions, we have 15 minutes of presentations, very tight, and 5 minutes, we have possibilities for 1 or 2 questions. And at the end, we have also another overall short break of 10 minutes about for summarizing the whole panel. Yeah, so that's the point. I would hand over finally to the presentation of Andrea. So please start the presentation.
So welcome again, everybody. It's Andrea from Politecnico di Milano. Thank you for hosting me in panel 9. I would like to special thank Eva and Thomas for coordinating the work in this, and not only. My presentation is about something that is not really new. It's about heating with air conditioner. The idea is how to deal with the speed up a little bit more the transition towards carbon neutrality. Heat pumps is nothing new in the market since they exist since years. The IEA, for example, is supporting a lot the adoption worldwide of those systems, and many commercial advertisements are proposing this kind of system, and also our colleagues are comparing those technology with the new technologies for heating homes. The actual situation in the residential sector in EU, you may see here that a lot of energy is spent in the residential sector, about 2/3 in space heating, and especially a lot of emissions are coming from the use of fossil fuels. That's something that is really not moving forward in the last years because of high cost for intervention, because of technical limitation, because of political ambiguity on fossil fuel. That's a real problem. The composition of the consumption in Switzerland is more or less the same. As you may see, the 2/3 is for space heating. As you may see in the table on the right, we have still a lot of fossil fuels like heating oil and gas that is decreasing a little bit, the heating oil, but is substituted by gas. And the use of direct electric heaters still there since 30 years. And the heat pump market is doing quite well, but not that fast as we expected. This is the status of the heat pump market in Europe. For 2018, there were sold more than 1 million units. France and Italy are the biggest market, but also the Nordic country that pushed a lot in the past for heat pumps. Air reversible, the stock is more than 6 million installed, mainly in, let's say, Mediterranean country. Around 1 million is installed each in Norway and Sweden. Market status in Switzerland is slightly different compared to the average Europe. Let's say the opposite. We have a lot of heat pumps, air, water, groundwater, very few air system. And as you can see from the graph on the right, the penetration rate of heat pump is not so high. In the meantime, with the work carried out within the AXE project, Heating and Cooling Know-how and Solutions, we made a lot of interesting observation of the market of several countries in Europe, around 15 countries. We have 17 partners. In the framework of the AXE project, we made a survey regarding also the incentive scheme in all countries involved in the project. What we found out is that there are a lot of schemes at national, regional, and local level. Mainly, it's direct rebates and subsidies or reduced VAT, zero or low loans. Look into the project material for have more detailed information. In case of substitution of inefficient system like fossil or direct electric are available interesting incentive in Switzerland. An installation are required to have a communal permit and also to respect the federal ordinance on noise pollution. The incentive level is different region by region, and the combination of improvement on the envelope of the building with more efficient system is highly promoted in Switzerland. The top 10 initiative started this study. At the end, we were wondering why we have few air heat pumps in Switzerland. And so we started a preliminary survey with designers and installers and especially users. We were looking for plans details, and plans about system consumption level, and also we made a small survey in place just to see how it works and if it works well and comfort condition. And the next steps in this study are to propose a more detailed study in order to understand really why is not supported this kind of appliance. First section we made here at local level where the open a discussion with installers, since they know how many systems are installed and where. And then we discussed also with the cantonal energy authorities in order to receive more information regarding the legal framework, and not only, but also the statistical data that you can see there. It's 1/3 of the residential building in the region are single family houses. More than 15% are using direct electric heaters in 2015. We have for the moment about 1,000 installation of a heat pump for heating. And please keep in mind that a number of installation is not considered at the moment, since we have office air conditioning and so on. So some part of the installation are not considered in the moment. After that, we started the research of good case studies and efficient case studies. We found out a lot of data regarding 4 single-family houses, Minergie, that means good quality of the envelope, that are new or refurbished. And then we have found also one non-certified house. These are the examples we have found not far from here. Let's say the region is quite big, and as you may see, we have since the north of the Alps until the south of Switzerland. So the climate is really different. As you may see, we have installation up to 1,500 meters in the mountains or in the plain nearby Como, for example, that is in Italy. One of the main problems typically for those installations is the noise control. What we have found in those case studies, the case studies were like 2-3 years at least completed. So it's something they are using machines that were produced like 5 years ago. So the noise level is quite low. As you may see, for the respect of the federal ordinance on noise, the distance between the units and the households and the other households is rather long because of they have to respect the values. That is really strict. Another problem for air heat pumps is typically the noise control in indoor conditions. What we have found that is really comfortable. We visit all the households that I've presented you, and also the tenants and the owners are really happy regarding the noise level. The inside units are could be, let's say, managed in order to be really silent during the night. Please keep in mind again that all installations were made 3 to 6 years ago, so the technology today could be even better. The most interesting part is regarding the consumption and cost. Here is just an example. We will provide a more extensive paper in the future, for sure. But for example, here you may see that in house 1, for example, we have a decrease of consumption from 25 to 11 kilowatt hours per day. This means more or less halving the cost for electrical energy. And please keep in mind that the consumption includes everything like new appliances, new heat recovery systems. This is a mini house. Heating, hot water, and the level of comfort improved impressively. So this is really interesting from my point of view. Another point is the investment. The investment for a new air heat pump compared to a similar air water is 30 to 50% less. The investment comprises the internal units and the distribution system. When using a traditional water distribution system, a new underfloor heating will cost like between 40 and 100 Swiss francs per square meter. So for a typical single family house without distribution system or brand new, the cost for having a proper water distribution is really high. For existing buildings, sometimes it's impossible to install this kind of distribution. But in any case, it is necessary to improve the installation of the household, since otherwise the power to install even for air heat pump is too big. So in existing building, we have also another problem that the space for installation typically is limited. So with air system, we may face those constraints. Just an example of two new single-family houses. You may see the total cost, but what is interesting is that for air, the total is quite smaller compared to the typical system with floor distribution, and that's the biggest cost typically. Regarding the overall performance of those systems, we may use, for example, just what we have typically on the web, like the top 10 website that is also supported by the HAX project. It's interesting to see that between the best products of the two categories, the difference in efficiency level for heating is not that high. So it's 0.6 points in terms of COP, seasonal COP, but it's only 12%. So we have to consider that also the air conditioners for heating are improving a lot their performance in the last years. Positive effects are also for utilities, like the reduction in peak load, the better load management, the removal of the lock-in time, service continuity. They can improve the primary energy factor of the whole system. They can pay less for compensating CO2 emissions. And these are like new market opportunities. They can sell heating as a service. The problem sometimes is that the tariff structure is not really consistent with energy saving. Sometimes it's also regressive. Here you can see a typical example here in where I live of regressive tariff, especially the network tariff is extremely regressive. When you consume more, you pay less per kilowatt hour. So the conclusion for the moment is that the cost benefit for users is clearly positive. The comfort level is good. They live there since years and nobody complained. Also, other part of the survey we made told us that it's really positive. In general, CO2 and energy consumption is less than 50% compared to before. Air-water systems are still more efficient, clearly, but investment costs are huge. Probably also an air system could be supported in a way by the market or by the government. But please clearly remember that for comfort and consumption reduction, it's really important, the insulation of the envelope. And something we want to address now is how to deal with the actual inefficient system, because the transition is too slow for the moment and we have to speed up towards less CO2. We have found a lot of studies supporting our idea since more than 10 years ago, and especially Nordic countries are working on this topic, and we hope to continue with this work in order to be more consistent. I would like to thank all the authorities who supported us in collecting data, also the building designers and installers, the family who hosted us, and the HAX project, the top 10 people, and the eceee people who supported us in keeping the project alive. Thank you. Thanks a lot.
Okay, yeah, thank you very much, Andrea, for the presentation. And yeah, then we open the floor for short questions. We have time for maybe 1 or 2 questions at the moment. I've seen the note, there's no question, but please enter it in the question answer section in the Hoover platform. And Eva, my co-panel leader, will have a look, but at the moment there seems to be no question, so you have a bit of time to think about it. And maybe there's the first one coming in, I think, for Andrea. So please, do you open your mic and answer the question?
I'll try at least. Those kind of schemes, we already have it also in Switzerland. You combine insulation with better systems. The problem is that, for example, in the real practice, the air heat pumps are not considered so efficient in terms of improving the overall performance of the building. So that's the main problem. Probably we have to revise a little bit the level of incentive, or either the level of performance for those systems. In this case, it depends on, let's say, as a political decision in this case. But as I told you, we have so many constraints in an existing building that we have to deal with. So it's something that we have to solve. But it's okay to promote both together, because without envelope efficiency, you cannot do efficiency at all. It's really hard, at least especially in Central European countries up to north. Probably in the south is slightly different. Thank you, Jean-Sébastien, for the question. I hope I have answered.
Okay, so that was the question. Okay. Yeah, then maybe one last question I have. Maybe you said there could be the speed efficiency could be improved. Is there the tenant and owner dilemma also a factor for this?
But in this case, I think not really, because in the cases I've studied are single family houses or bifamiliar houses, and one of those was the owner lived there. So it's something strange, but the case studies are not so in line with this kind of barrier for energy efficiency. But in general, I imagine that another barrier could be the cost for electrical energy, and the cost for gas. Probably it's another problem also in Switzerland. But in any case, if you give some incentives and improve the comfort condition, it will solve almost all the barriers. So between tenant and owners, and not only. That's the main problem.
Okay, yeah.
It's hard to find single family houses not owned by, not lived by the owner. That's the point.
Okay, yeah, thanks also for this. And I'm having a look at the chat, but I think there's no further question. And also looking at the time, then we thank again for Andrea for presentation and giving the answers. And then we head on to our next presentation, our next presenter. And especially our next presenter is Sophie Attali. And of course, many of you know her as she's an expert and consultant in area of energy policy and efficiency for a long time. Especially on products, and she's working, for example, market transformation and European institutional policy frameworks, demand side management, yeah, and so many on. And also in this context, of course, it fits very well to have her presentation on the question, also heating and cooling, fixing problems by sufficiency measures or investing in new equipment by efficiency. Yeah, so please start the presentation, and I'm handing over to Sophie. Please start the presentation. Thank you.
Hello, I will be presenting this paper in the name of my co-authors, Maaike Hepp and Eric Bush. I'm Sophie Attali from Git Top 10, and I'm going to speak about heating and cooling equipment and how we can fix the problems, hopefully with sufficiency measures and or investing in a new equipment with efficiency measures. Actually, this is what we are doing in the framework of a Horizon 2020 funded European project called HACS for heating and cooling know-how and solutions. And our idea was to work on these topics because they are really a huge energy stakes in Europe, even though users are not aware about this. So it's 50% of the EU greenhouse gases emissions that are for heating and water heating and space heating. And there are also a high number of installed systems that are old and very inefficient that should be replaced as soon as possible. However, we want to promote both energy efficiency and sufficiency. So what we want to do is to identify the most efficient models per technology, but also to promote no-cost or low-cost measures to reduce energy consumption, energy use, energy bills, and improve comfort. This project has started in September 2019 and will last until September 2022, so we are mid-state of play, and I'm going to present our activities so far. First of all, I need to make a first digression about the top 10 approach. So, because I speak about top 10 because the HACS teams have been working together for the past 15 years on the top 10 project. We are 15 countries and working together. Our goal is to contribute to climate change mitigation. There is no commercial interest in this, by transforming the market towards more energy efficient products. And we know that there are energy efficiency differences between electrical appliances that provide the same service, but these differences in efficiency are still very significant. So it's important to choose the good products when you buy a product, especially for heating or cooling, that will last for at least a decade. So what Top 10 does is that it facilitates the process of selecting this product by displaying on its website, in free access, the latest market information on best products that are available on the market now that you can really buy. And this transparency has benefits for a lot of targets, so for consumers, of course, but also for producers, especially at the beginning, the front runners that get some, let's say, free promotion for their good products. But we know that step by step, the energy efficiency triggers down the range, and then from manufacturers to other manufacturers because it becomes a competition criteria, etc. So it's good for producers, it's good for retailers and installers, it's good for policymakers that can base their policies on the benchmark we identify. It's also helpful for NGOs that have concrete messages that they can relay to their own target groups. But for heating and cooling devices, this is a bit different from the traditional top 10 approach, because normally we used to work on very standardized plug-in products that consumers just pick on the shop and can even buy on the internet. But with heating and cooling equipment, it's different because they interact with the building. So we don't want to promote a super efficient product that may be oversized, and in the end it consumes more than a poor performing product that would be smaller. The consumers, they rightly rely on installers and they don't choose the product themselves. However, they may need advice on how to speak with installers to better understand the choices they are proposed by the installers. And also, we know that the most beneficial action from a collective and from an individual perspective is very often to reduce the energy needs, that is, to work on the building envelope. So we cannot just display best available products like this. We need to add a lot of advice around this and a lot of warnings on what consumers can do very easily to be sure that they make the good choice. So we have started by a HACS baseline report to map out the situation at the national level and to prioritize the pragmatic actions that each country is going to work on, because it really depends. The situation in Poland is not the same as the one in Spain and in Sweden, and you can't just promote the best technologies if they are not at all used in your country, for example. So we work on two axes. The first one is that for all consumers, but especially for those who cannot or who don't want to invest in a new system, maybe because they are not owners of their homes, etc., we recommend strategies to improve the comfort and air quality and lower energy bills with the existing system or the non-existing system. So in the case of air cooling, how can people have a better comfort in the summertime without investing in an air conditioner, for example? And the second axis is for the consumers that are ready to invest, or that we will make aware that they should invest because their current system is pretty old and outdated and not efficient. Then we provide a list of most energy efficient products to enable the consumers to make informed decision. So for example, once you've had a professional advice that tells you that a heat pump system would be a good idea for your home, and you know the size and you know the type of heat pumps, etc. So all things being equal, there are large performance differences between the products that are on the market. And we have seen, for example, for heat pumps, that lifetime costs can increase twofold between the products we select and the ones that are available on the market. So how do we do this? We have set up 15 websites that are tailored to their national context, and one European platform that is more for benchmark and researchers. And I've put the URL here, and it acts as an open doors to all the HACS websites so far. On these websites, we have lists of best available technology products, so what we call BAT products, for air conditioners, electric water heaters, solid fuel boilers, heat pumps, comfort fans, circulation pumps, local space heaters, and also taps and shower heads. And in some countries, they also have windows or other very specific products, because they have the tools at the national levels to do this, to develop these product lists. So to start to develop this product list, we have centrally, to use synergies, we have centrally developed 8 what we call criteria papers. So these are papers that are available from download for anyone, gathering information on each product category. So what is this product? How does it work? What is the regulation? What is important for energy efficiency? What is important for consumers, etc.? And based on these criteria papers and the central list that are on top10.eu, the European HACS teams work on the most adapted products category for their country and adapt the selection criteria, because even though we have the same regulation across Europe and we very often have the same producers, this is less true for heating products, but it is very true for some of them, we have difference in the supply, and they are not always efficient depending on countries where they are offered. So what we do, the HACS teams, is that we do a kind of a continuous market study to develop markings in the jungles of products, because there are hundreds of products and there is no way single consumers can do what we do, this market study for these product categories. So this is how it looked like, so product list on the Hacks and Top 10 website. This is for the electric water heaters, where we have selected 42 products based on their energy efficiency. On each product list, you can find a page with the selection criteria, so the methodology is transparent and public, and we try to make it as easy as possible so that consumers can understand what is a good product if we don't have it on our list, for example, because the market always moves faster than we can move. And we also have a link to an advice page that I'll come back about this later, that is very important. And if you click on one of these products that interest you, you come to a product detail view. You have a kind of product fiche where you have, normally you should find all the information that interests consumers, but also all the energy information and some information about the cost, etc. So the issue is, how can we include as much as possible sufficiency, concepts and ideas in this? So, and it's the one way of promoting these sufficiency measures is to use the advice pages. So in these pages, we warn as much as possible, we encourage the visitors and the consumers to have an upstream consultation with energy advisors. So in most European countries, this service is available, very often for free. Or there are huge rebate programs right now to improve the buildings, etc. So what should be done before just saying, oh, I'm going to change my heating system without thinking a bit further? So we first advise this. Sometimes we provide links to certified installers that are especially trained to promote the most efficient solutions. And we also provide alternative solutions, so especially to avoid installing cooling equipment, because this is really easier, but also we can get into the details. And for this, we have produced a catalog of key topics. This is also available for downloads. This was meant for the Hacks teams to provide advice on heating and cooling. It's a kind of a library where they can find all the topics, or all, that would be a very long list, but as many topics as possible to communicate about this idea on how to reduce the use of heating and cooling whenever it's possible and why to do this. So we first introduced the concept for comfort, what is this exactly, and air quality, and how we should maintain both and how we can maintain both. So we provide contextual information that is on climate change, on money savings, on the multiple benefits that are linked to improving your comfort and your changing your heating systems or improving it. We provide also information relating to the equipment itself. So how can you limit consumption by insulating pipes or using thermostats and programmers, etc. We have a section on relating to users' behavior. So, for example, how to deal with windows. So the opening, the closing, the shadings, the temperature settings according to the room, according to the time of the day, how to tackle water leaks, etc. And we also provide advice for choosing highly efficient heating and cooling equipment. So this is just to give some tips, very generic tips about the pros and cons of the available technologies. How do you choose your transmitters, or how do you maintain, how do you size conveniently your equipment? And finally, we also have a section on how you use your heating and cooling equipment in an efficient way. So with a good ambient temperature that is maintained, that you should maybe check the tightness of the refrigeration circuits, that you can use eco-label wood pellets and chips, etc. We also have a hack calculator. That's again a very generic tool because it's there are so many targets, it's so broad. So the idea is to help consumers and installers to get the first generic assessment of their current heating system and then compare it with potentially new and more efficient alternative systems. So you enter very basic personal data about your home, the dwelling area, the climate zone, number of inhabitants, etc. You select the alternative heating system or systems. You can select several that are more efficient. You select also possible home insulation measures that you could take to reduce the energy demand. And then the calculator compares the results in terms of energy need, energy consumption, cost and CO2 emissions. So here, maybe this is one aspect with sufficiency, is that the calculator shows that very often the insulation measures are more beneficial than only changing the heating system. And we think that it's important that consumers are made aware of this, that given the climate crisis, there is a need to really tackle as deeply as possible this issue with the renovation. So the HACS websites are the basis for many communication activities. I won't go into this subject now, but you can read the paper. Our idea is to reach as many as visitors as possible and to involve them to make sure they use the information we provide. We have policy recommendations where we try also to put in sufficiency aspects with limiting size of products, for example. So far, collectively, we have prepared 53, I think, policy recommendations at different levels. So EU regulation, national regulations, financial incentive schemes, or for public procurers. And we also use the website's content for partnerships with stakeholders that we call multipliers, because they actually multiply our messages by relaying it to their own target groups. So that's my concluding slide. We have so far reached 162 partnerships with a wide variety of multipliers that use the HACS content. So we're very happy to work with utilities, energy agency, installers and retailers that are really key for this project, but also university and researchers. So that's all for me. I thank you very much, and I hope I will be answering your questions. Thank you.
Yeah, thank you very much, Sophie. And yeah, we have already seen there's a question already in the chat, and you answered it also in the chat, but it would be better for all the attendants that you explain it also, because we have these two platforms. So, Sophie, would you like to answer the question from Jean-Sebastian?
Yes, so the question was if we also look at the compliance with the energy labeling and the eco-design regulations. And of course, we do in a sort of a limited way because of our means, but most of our selection criteria are based on these two regulations. So we really look for the information that manufacturers should provide according to these regulations. We recalculate what is possible to calculate, and then when we have doubt, we don't display online the products. So I can give two quick examples. So for example, for heat pumps, it's pretty difficult to find all the information for both, for all the temperatures, etc. And sometimes manufacturers do not provide it, whereas they should. This is one example. Or for ventilators, for example, there is no energy labeling. However, the eco-design regulation demands that manufacturers publish two informations from which we can derive an energy efficiency index. That's the per watt air, oh, I forgot the name in English, the volume air that can be moved. Okay, so if we find these two informations, we can then calculate the energy efficiency that is the basis for our selection criteria. But if we don't find it, then we can write to the manufacturers and hopefully they react and provide the information, but sometimes they don't, so we can't go further.
Okay, yeah, thank you for answering this question. Also, of course, we will have later on the presentation from Hélène on especially the fan topic. Yeah. I think this could explain it more in detail. And I'm also having a look at the chat. Maybe, Sophie, you mentioned that also a link should be corrected, top10eu.hacks. So
sorry.
We write it also.
In my presentation, I was dyslexic. Sorry about that.
Okay, so we will put it also the new link also in the HUFA link, so then everybody can see it and access it there in the aftermath.
Thank you.
Okay, so there's, I think, no further question at the moment I can see, but looking at the time, it's also yeah, quite a point maybe coming back later on in the discussion when we have all heard all the presentations. And now continue directly with the next presentation and our next presenter. And yeah, the next presenter is Srishti Sharma, and she will give us a presentation on the topic of evaporative air coolers and standardization and labeling, and the roadmap of affordable sustainable cooling solutions in India. And Srishti is working as a research analyst there at the AEEE under buildings and appliances area. and she's working especially on energy access, but also efficiency of appliances, sustainability, and these broader topics. So then I will hand over to presentation of Srishti, and yeah, please start the presentation now.
Hello everyone, greetings of the day. Hope you all are sound and safe. I'm Srishti Sharma, Research Associate at AEEE, Alliance for an Energy Efficient Economy. Today I'll be presenting the paper titled as Standards and Labeling for Evaporative Air Coolers, a Sustainable Roadmap to Affordable and Sustainable Space Cooling Solutions in India. Before starting the presentation, I would like to share this moment and thanks eceee Summer Study Group for giving me this opportunity. I would also like to thank and acknowledge the co-authors of this paper, Mr. Tarun Garg and Mr. Akhil Singhal from AEEE. This paper would not have been possible without the critical inputs and support. Also, I would like to show my gratitude towards Dr. Satish Kumar and Dr. Khushbu Gupta for their constant support and guidance throughout the paper. Last but not the least, I would like to acknowledge and thank my panel leaders for providing their valuable inputs. Now moving on. Please note in this presentation I'll refer evaporative air coolers as EACs and room air conditioners as RACs. My presentation will cover the content related to background information, brief information on evaporative air coolers, Bureau of Energy Efficiency Star Labeling Program, Indian Institutional Landscape for Appliances, and follow up to this, I'll provide insights from the comparative analysis of EAC standards adopted nationally and internationally, and the identified gaps and recommendations for India's EAC sector established on the basis of review of EAC standards adopted internationally. As we know, thermal comfort is defined as a state where an individual is satisfied with the thermal conditions of the surrounding environment. As the human body is adaptable to local surroundings, the thermal comfort of an individual usually varies by region and is influenced by social culture and acceptability. Thus, what is comfortable for an individual who is used to live in hot, dry, humid climate may differ from an individual from a cold and dry climate. Thermal comfort is affected by various factors such as microclimatic conditions, which include temperature, relative humidity, and other factors. Access to cooling for attaining thermal comfort is no longer a luxury, but has become a necessity to ensure overall quality of life, health, and well-being. Thus, an exponential upward trend is expected in India's space cooling energy consumption by appliances such as evaporative air coolers and room air conditioners. India has around 3,000 cooling degree days. However, it is one of the countries with lowest access to cooling, with per capita space cooling energy consumption at 69 kilowatt hours as compared to the world's average of 272 kilowatt hours. India, being one of the fastest growing economies, will result in an increased demand for better quality of life and thermal comfort in coming future. On the other hand, it was estimated that significant share of household will not have the purchasing power for the RACs in the coming decade. Despite having low penetration, RACs account for significant share of space cooling energy consumption and carbon emissions. They're also not climate friendly as they use refrigerant with high global warming potential. It has also been projected that affordable housing sector will add another 360 million square meters by 2022 to the building footprint. Therefore, all these factors will lead to an increase in demand for affordable space cooling solutions, which in turn will require deployment of affordable and sustainable space cooling solutions such as evaporative air coolers. Now, giving you all a brief about evaporative air coolers, they're also known as swamp and desert coolers and can be used in residential and commercial settings. These appliances use water, which is a natural refrigerant, and used to cool the air through the fundamental principle of evaporation of water. Thus, EACs are a non-global warming potential refrigerant-based space cooling technology. As you see in table number 1, there are 3 types of evaporative air coolers. Direct evaporative air coolers, here referred as DEC, indirect evaporative air coolers, here referred as IEC, and indirect direct evaporative coolers, here referred as IDEC. In a DEC, air passes through the cooling pad of an EAC, leading to direct contact between air and water. DEC help reduce air temperature through evaporation of water along with the conversion of sensible heat into latent heat. During this process, specific humidity is added to the cooled air. This technology is best suited for residential settings in hot, dry climate zones. Whereas in an IEC, heat exchanger are used to reduce the temperature. With the help of heat exchanger, there is no contact between air and water. No specific humidity is added to the cooled supply air. In contrast to DEC, IEC can operate effectively in humid climate zones. This technology is best suited for large and industrial spaces where addition of humidity content in the supply air has to be avoided. And IDC is also known as two-stage evaporative air cooler. During the first stage, air is cooled through IEC followed by DC in the second stage. Air from the secondary and primary air stream does not come in direct contact. Here, heat exchanger and the cooling pad are used in the first and the second stage. This technology gives more cooling effect than IEC and DC alone. The final cooled air has somewhat increased humidity. Therefore, this technology is best suited for large and commercial industrial spaces where there is a significant temperature drop requirement and the ambient air also has low humidity content. Performance-wise, DAC are more efficient than IECs and IDEC are the most efficient evaporative air coolers. Now moving on to the EAC market scenario in India, EACs are more affordable and sustainable space cooling technology. They are cheaper. They're 85% cheaper and consumes around 56% less energy than a conventional RSC. Further, if EAC installed with efficient fans and pumps have energy saving potential of around 20% in the coming decade compared to business as usual scenario. The current penetration rate is 15%. Also, their market is subjected to grow at a CAGR of 14.2% during 2019 and 2025. However, 70% of the EAC market is unorganized. There is no standards and labeling program available and is usually made to order. India's SNL program implements the push and pull strategy in appliance market for bringing market transformation. The push for the elimination of least efficient model by the application of minimum energy performance standard and a pull for consumers to opt and purchase a highly efficient appliance by the application of informative energy performance label. Thus, the development of SNL program for EACs should lead to market organization by the elimination of low-performing EACs that do not comply with the SNL norms. Therefore, this paper has provided an overview of India's policy, regulatory, and institutional landscape for the SNL program. It has established a comparative assessment within the standards which have been adopted nationally and internationally for EACs. Moving on to the national policy and regulatory framework for appliances, I will give you a brief about Bureau of Energy Efficiency Star Labeling Program, which was established in May 2006 to provide clear information to the consumers about the energy saving potential of the appliance to make an informed decision. Under this program, there are two main component standards. They prescribe limits on energy consumption of an appliance and labels are affixed to products and give consumers necessary information to make informed purchase decisions. Bureau follows a typical process for each appliance as shown in this figure. Under inception and interim phase, the appliance selection criteria depends upon market size of the appliance, share of organized and unorganized market, total energy consumption, energy saving potential, ease in implementation of the standards, availability of appliance test procedure, and labs. Then comes the development phase. For each appliance, Bureau established separate appliance technical committees comprising of key experts and stakeholders, which play a significant role in establishing MEPs. This is followed by implementation phase. The committee has to register themselves on the Bureau's web portal and submit the application form with the required documentation. This is followed by model registration. The application is verified by independent agency for monitoring and evaluation along with the state designated agencies. The application of the star label is allowed after their approval. Then comes the enforcement phase. Monitoring and verification, check and challenge testing of the label appliances is conducted by Bureau. And they verify whether the energy performance of the labeled appliances are matching its performance claims or not. Then last step is compliance mechanism. The state designated agencies appoints an inspection officer for ensuring compliance with the regulations. In case of non-compliance by the committee, the state designated agencies informs Bureau to disqualify such appliance and informs the State Electricity Regulatory Commission. Thus, SERC, the State Electricity Regulatory Commission, appoints an adjuncting officer who follows the final adjunction process. This is how the SNL in India operates. Now, moving on to India's institutional landscape governing appliances is inclusive of various ministries, central and state level nodal agencies, as shown in this figure. The SNL scheme is mainly administered by Ministry of Power and supported by Ministry of Consumer Affairs, Food and Public Distribution. B is majorly responsible for rolling out new appliances under the program and its overall administration. CPRI provides technical support and provides expertise for development of performance testing procedures. The SERCs and SDA support the enforcement of SNL within the respective states. The Bureau of Indian Standard, the BIS, provides pivotal support to the standards and labeling scheme by supporting the development of testing and quality standards. On the other hand, ozone cell under the umbrella of MOEF and CEEE, which is Ministry of Environment, Forest and Climate Change, had launched ICAP, which is India Cooling Action Plan 2019. The ICAP 2019 is inclusive of a long-term integrated 20-year outlook across sectors on India's cooling demand, technology options, refrigerant use, and energy consumption. ICAP Space Cooling Building has specified a short-term recommendation that deliberates upon the development of MEPS for AECs. ICAP has also identified a steering committee inclusive of BE for the implementation of ICAP. However, ozone cell at this point of time is not the part of overall SNL administration and can only be recommended to take up actions as climate mitigation measures. Now, I will provide you insights from the comparative analysis of EACs standards adopted nationally and internationally. The standards were compared on the basis of 4 main categories. First is water consumption and quality. From the figure, we can see it can be observed that most of the standards adopted by the country does not give much weightage to water consumption and quality. The water quality parameter is adopted within the ASHRAE and eceee testing standard. The water flow rate has been specified by ASHRAE testing standard. An ECC testing standard use water consumption interchangeably to the ASHRAE's testing standard water flow rate terminology under section 6.5. However, ECC testing standard does not capture the water consumption as such. Thus, it can be said that efforts have been made to monitor the water flow rate. However, water consumption has not been captured. Water being a precious resource and depleting by each passing day shall be one of the parameters to measure and standardize and should be standardized to avoid excessive water use within the evaporative air coolers. Now, under the performance parameters, energy performance and power consumption has been covered by all the standards reviewed under this paper. Indian standard has stated that power consumption at zero static pressure shall not exceed the specific range of 95 to 500 watts. Iran MEPS and label and ECC testing standard has specified energy performance in terms of EER ratio. California Appliance Efficiency Regulation has specified ECER as the parameter for evaluating energy performance. ASHRAE testing standard has specified power input testing requirements. Thus, there shall be common metric like EER that can be used to compare and quantify performance of products from different countries. The noise level of an EAC has been covered under Indian standard and Australian standard. The requirement of safety has only been covered by Indian standards for evaporative air coolers. Other important parameters, namely airflow and cooling effectiveness, has been covered by all the standards for the study, whereas the static pressure has not been covered by Australia, California, and Iran standard. Under testing protocols and MEPS, all the above mentioned standard and MEPS have provided the information regarding testing protocols for evaporative air coolers. However, MEPS for evaporative air coolers have been defined only by Iran as of now. In addition, guidance and instructions for manufacturers and eco-mark has been covered by only Indian standards. The details regarding different type of evaporative air coolers have been specified by ASHRAE and ECC testing standards. From the review of MEPS and testing standard for evaporative air coolers adopted nationally and internationally, the following gaps have been identified and recommendations were provided. It was observed that absence of MEPS and label for evaporative air coolers at national level. The seasonal energy efficiency ratio, which is SEER, would be an ideal parameter to evaluate the energy performance of an evaporative air cooler annually. For the development of performance label, comparative assessment of labeling programs available globally could have been undertaken. Secondly, there is a requirement to build an ecosystem around EACs in India, including testing infrastructures, operation and maintenance services, training and development, and integration with academia. Also, there's a lack of testing standard for different types of evaporative air coolers, as state-level nodal agencies and civil society organizations could support the SNL program in framing set energy performance testing standard for different type of evaporative air coolers. Also, based on the identified gap, it was recommended that Indian standard for evaporative air coolers could also focus upon water consumption to cover the overall performance of evaporative air coolers. Simultaneously, capacity building workshops could be conducted by CSOs and state-level nodal agencies for increasing the number of trained experts in the sector. And CSOs could also carry an in-depth market transformation potential study to identify the exact potential of evaporative air coolers in the commercial segment. To conclude, I would like to state that with increasing purchasing power and affordable rates of evaporative air coolers will make them the preferred solution for achieving thermal comfort. Further, EEC market in India is projected to grow at a CAGR of 14.2% during 2019 and 2025. and is majorly unorganized. Thus, eceee might contribute to increased energy demand and serve environmental effects if left unchecked. Therefore, prevailing conditions postulate an opportunity to develop mechanisms such as standards and labeling program to minimize the impact of ecees on environment and stay ahead of demand curve. It was observed that water consumption by EAC had not been adequately covered by any of the standard, and energy performance have only been covered by Iran standards and MEPS. Therefore, India shall focus on both water and energy performance as mandatory regulations under the potential standard labeling program to support the climate change actions. While there is no standard and labeling program for EACs in India, developing it could bring market standardization, as it will mandate the sale and purchase of certified products only. This will also aid in evidence-based policy research for the future. Therefore, EAC's quality and performance can be leapfrogged by mandating specification and MIPS at par of international standard. Henceforth, it can be concluded that roadmap for an effective transition to evaporative air cooler can be closed through the implementation of SNL program for the deployment of this energy efficient and sustainable technology. Thank you all. I would request you to forward all your questions and queries to the following mentioned email IDs. Thank you.
So yeah, thank you very much, Srishti, for the presentation. And maybe you have seen already in the chat, at least for Zoom, Eva's transferring it. There's the first question from Andrea. And how do you deal with the Legionella problem and maintenance? So would you like to answer the question, Srishti?
Yeah. Thank you so much for the question. It's an interesting question, and this is the problem which all the evaporative air cooler users face in India, how to clean it, how to maintain it. Though currently it was not in our purview of the study, but while developing the MEPS or the standard, we will look forward to how to include this as a parameter. So thank you for nudging this question to me. I'll surely take it as an to the stakeholders while developing the minimum energy performance standards for India. Thank you so much.
Okay, yeah, that was the first question. Thank you very much. Maybe before others might have also additional question, I have also one question, and is especially related, of course, the work you're doing is quite important. Are you also aligning maybe with other countries or areas who are also the same kind of cooling systems could be interested? Are you also connecting with other countries and standardization approaches? Can you tell me something about that?
Can you please repeat? I didn't understand.
Okay, I try to repeat.
Yeah.
I also, you're now focusing on the India market, of course. And of course, you have checked other regulations, but are you also in contact with other countries or areas where also these kind of cooling systems could be interesting?
So at this point of time, so AEEE is working along with Bureau of Energy Efficiency, which is a body under Ministry of Power, along with eceee, which is the state development authority for the standards. Mm-hmm. So we are working together to form a MEPS. So while developing the MEPS, we will for sure get in touch with different bodies who have developed standards already, like Australia, California, or Iran. So we are in touch to understand in detail of how they have prepared the certain standard, what all base testing scenario they have considered. So yes, we are doing that.
Okay, yeah, that could be especially, I think, worldwide, very interesting applications with similar climate conditions. So
exactly. Yeah. Thank you so much.
Okay, so then I'm also having a look again at the chat, but I think at the moment there's no other question. At least I cannot see one. Maybe for later. Oh, there's one from Niroshini. EAC is mostly on grid use or urban and rural split. Yeah. So Srishti, you have to unmute. Yes.
Thank you so much for this question. Very interesting question. So yes, in India, mostly it is on grid based. Currently, it is not solar or PV based. And yes, it is being used in India, both in rural and as well as urban setting. The ratio is obviously more in rural because of the affordability segment. Yeah.
Okay, yeah, thank you. So that's for answering these questions. And
thank you so much.
Yeah, so looks that we already, of course, we have later on, again, the possibility for additional questions in a bigger context. And of course, you can already enter during the presentations question also for the next ones. And as there's still no further question, then thank you again for Srishti and your presentation. And yeah, then going on to our next presentation, and already the last one of our panel for this one, for panel 9.1 for this early session. And next presentation will be given by Hélène Rochard, who's Energy Efficiency Project Manager at also the Top 10 initiative in Switzerland. And she's working on appliances, also in the context of EU eco-design and energy labeling regulations, on the respective product issues, the markets development, and especially on product testing for better regulation. And especially in this context, of course, also her presentation will be on the topic on environmental dumping of inefficient comfort fans in the European Union. And for this, I will now hand over to Hélène and her presentation. So please start the presentation now.
Dear ladies and gentlemen, thank you for participating to this presentation on the environmentally harmful dumping of inefficient comfort fans in the European Union. So for this presentation, I thought I would walk you through the steps that we took at Top 10 that brought us to these findings. For those who don't know Top 10 is a platform for consumers that show the most energy efficient products that are available on the market. So it's a tool for consumers to find and choose efficient appliances when making their purchase decisions. So in preparation for the summer of 2018, we thought that we would like to make a product list for comfort fans in preparation for the summer. And since comfort fans can serve in many cases as an alternative, as a good alternative for air conditioners, it would be a way to not only save energy by buying a comfort fan instead of using an air conditioner, but also by buying a good comfort fan as opposed to an inefficient one. So as you probably know, comfort fans come in different types. So you have pedestal fans, ceiling fans, floor standing fan, table fan, tower fans. Those are all very common types of fans that are available on the market. So when making a product list at Top 10, so what we need to know is what constitutes an energy efficient fan. So what is a fan and how do we measure the energy efficiency of the product? So luckily there was already some work out there, and there were already some product information that we could use to define this. So the definition of the product is that these are appliances that are designed to create an air movement around or on part of a human body for personal cooling comfort. The market for these products is very large. In 2020, it was estimated that there were 52 million units sold in the European Union, and the sales of these products are highly correlated with the heat waves. And as we know, these heat waves are always more and more common, and this is directly a cause for these very large sales of comfort fans. So to assess the energy efficiency of the fan, there's a metric called the service value. And the service value corresponds to the amount of air that gets moved per minute for each watt of consumed energy. So the higher the service value, the more air is displaced with less energy, and the more efficient the fan is. So to optimize this value, you can either lower the amount of watts consumed, or you can increase the amount of air displaced. And to do that, you can optimize the design of the blades so that they displace more air. And to calculate this service value, there is an existing measurement method that is available. It is the measurement IEC 60879. It was updated in 2019 and includes tower fans and bladeless fans that were not included in the previous versions. So with this information at hand and a way to calculate and to measure the energy efficiency of the fans, we looked at what regulatory requirements are already existing in the European Union for these products. So these products belong to the Commission Regulation 206/2012 for air conditioners and comfort fans. And in this regulation, this eco-design regulation, there are some information requirements for these products. And the reason why there are information requirements and only information requirements, no requirements on energy efficiency or noise, is because while making the regulation back in 2011, 2012, there was not enough product data of the products available on the market. So for this reason, they introduced information requirements with the goal of gathering enough data for the later revision so that they could introduce other eco-design requirements for energy efficiency during the revision. So the revision is actually ongoing, and based on this review study, however, sadly, the review study does not go very deeply into these products and mainly focuses on air conditioners because that's where they see the biggest saving potential compared to comfort fans. And they base themselves, sadly, also a lot on the previous study where no new information really is added. So the outcast for these products, for the regulation of these products, seems to be very bleak. And so minimum energy performance requirements, MEPs, for these products are not uncommon. They already exist in many countries, and in Asia, for example, in China since 2008, Malaysia, Vietnam, soon in Indonesia. So this is not something that is unknown. It already exists. And for the products that are sold in Europe, most of them, 95% of products sold, are imported from China. So there is actually existing knowledge out there for these products. So with this information at hand, we knew what information we needed to ask for, and we knew that this information is available because it is in the product information requirements. We went out and we did a market assessment of the products that were available on the market at that time. So in our assessment, here are the findings. So we evaluated 158 products, and out of these products, only 8 products declared the information that is required by the information requirements of the European regulation. For the products where we did not find any information, we asked the manufacturers, we contacted them directly, and the importers, and we asked them for the information. What was very surprising, actually, was that in many cases, they did not know what it was. So we had to explain to them what it was, what were these metrics, what were these values, and we received from them enough information to be able to assess 67 models. So in total, out of our whole sample, we had 75 models for which we had the product information where we could assess and compare the energy efficiency of the products. And this translates actually to 89% of products that were assessed did not comply with the regulation, which is, after almost 10 years of it being into force, actually quite shocking. So as I said, a big part of the products that we have in Europe are manufactured and are imported from China. And we wanted to see how these products performed compared to the minimum requirements that are in China. Because perhaps we thought maybe we do not have any eco-design requirements for energy efficiency, but since they are produced in a country where there are these requirements in place, maybe that those fans actually already comply with the MEPs that are in China. And actually, very surprisingly, out of the 75 models we evaluated, 32, so 42% of the sample did not comply with the MEPs in China. And it is also expected, because of the reporting bias, that this proportion of fans that do not comply with the Chinese MEPs is actually even larger. Because as the reporting bias goes, it's usually the good performers that report and the bad ones don't declare data. So it's very likely that the products for which we did not receive any data, that these products do not comply with the Chinese MEPs. And based on this, this is a clear case of environmental dumping, where the products that are being exported cannot be sold domestically because they do not fulfill the energy efficiency requirements that are in force locally, but they are being manufactured to be exported to regions with lower standards or no standards, like in the European Union. And this is actually something that undermines the ability of the importing region to fulfill their environmental objectives, and is also contrary to the interest of the consumers, because they could very well be having better products, but instead they receive the products that are inefficient and bad for that cannot be sold in the country of manufacture. So with this information, we still did our product list. So on our first product list that went online in 2018, there were 41 models. And for each type of fan, we made some very simple selection criteria. So we defined a service value for each fan type. And we still looked at how many of these fans were non-compliant with the Chinese MEPs, and out of these fans, about a quarter of the product list was not compliant with the Chinese MEPs. So this, as a reminder, is a list of the best performing products in Europe. So after 3 years, so in 2021, every year we went back to the manufacturers, asked them for product data. We wanted to see if there were any improvements. And one thing that was encouraging is that we received more data. So now the product list grew to 123 products. And we could strengthen the criteria for table fan and floor standing fans. But still, out of this product list, 9%, so that is 12 models, still do not comply with the Chinese MEPs. And that is still very shocking to see that the best products in Europe, some of the best products in Europe are not allowed to be sold in China. So based on these findings, there are a few recommendations that we would like to do for the European Union, and this practice of environmental dumping can easily be avoided by aligning the requirements with the ones of the exporting countries. These requirements have been into force since 2008, so it should really not be difficult for the European Union, the European Commission, to adopt these requirements. And they could either harmonize or introduce more stringent requirements than the one in China. And comfort fans have been, in the review study, neglected. They have not received the attention that they deserve, and that is mainly because they were in the shadow of air conditioners. And so it is important that MEPs and an energy label be included in the next revision of Commission Regulation 206/2012. The draft included a proposal for these requirements, and we believe that it's very important, that it's crucial that this proposal remains in the text and is not removed. And with actually 52 million units sold in 2020, this product group is actually very large and could be a product category on its own. The number of units sold in the European Union is high enough to meet the requirements for its own eco-design regulation. Let me remind you, it's 200,000. And also the energy saving potential is also significant. So this product is large enough, and we would also suggest that these products be separated from air conditioners and be their own regulation. So based on this, I'm very happy to answer any other questions you have. Please feel free to contact me. Here are my contact details. And thank you very much for your attention.
So yeah, many thanks, Hélène, for your presentation. And as you can see, I had already to change my background now to fit to the topic. And yeah, very interesting presentation. And I'm looking at chat at the moment. There's from the audience not a question, but maybe the people have time to think about it. I have 2 questions at the moment. And first of all, the first question would be, have you encountered the European Commission officials or as part of the revision process of eco-design with your results? This would be my first question. And my second question would be, would you see also for other product groups the risk of environmental dumping? Maybe not only in the EU, but in your area of work. So that's the second question. So.
Yeah, so to answer your first question, yeah, we did approach the Commission, and I believe that in the annex of Task 7, there is a summary of our findings. So from the market assessment we made, at that time we had less investigated how these products compared with the Chinese MEPs. So that would be something that has been added to the assessment. And also, I think that when we were in contact was in 2018. So since then, there has been new data from Top 10. And for environmental dumping, I see this as a risk for any product that is not regulated. There's possibilities. Environmental dumping is a legal practice. It's nothing illegal, but it's not only in terms of energy efficiency, it's also in the management of waste or resources. So any product that is not regulated, there is always a risk of that. And it's also any products where our standards are lower, our requirements are lower than other regions of the world. There is also a risk of environmental dumping.
Okay, yeah, thanks, Hélène, for this. And meanwhile, already said there was another question from Andrea, and for ACs, it's similar situation in terms of dumping with this question. And I think you can see it. And the maps were higher than in China, right?
Mm-hmm. So for air conditioners, well, there are certain regions that are very ahead, and they update more frequently their regulations than the EU. So the revision for the air conditioner regulation is also very urgent because when it was introduced, we were really at the top, but now the products have improved. And so that is also a product category that where there is a risk, less urgent, let's say, but it is definitely a risk, yes.
Mm-hmm. Okay, so this has to be also kept in focus. And in this context, I've seen also from Hans Paul, there's another question, if you have estimates for the saving potentials.
Mm-hmm. So the saving potential, there was a saving potential that was estimated in 2008, and that was in the first preparatory study, and that was 1 terawatt-hour of potential savings. But you have to keep in mind that in the study and in the review study, it was expected that the sales of comfort fans was going to go down, and instead it took the absolute opposite direction. So we think that this saving potential of 1 terawatt-hour is actually very, very conservative. It should be much higher. And also, we believe that also the saving potential was also perhaps underestimated. Underestimated, because this issue of probably environmental dumping was not really considered, that products were going to be expressly manufactured for exports. So yeah, it's the numbers we have are very conservative.
Yeah, I think just to remember, I think you had numbers shown, or in your paper, it more than doubled compared to the original estimates in the preparatory study, right? So
yeah,
much more. It's more than factor 2 or even more. So big difference. Okay, thanks for this. Then there's another question already from Andrea. If it's possible to set faster changing maps in the regulation, in your opinion? Of course, we need maps first. And have we examples for quick policy instruments? Fast track, I think, is meant here. Yeah.
Well, here, something that would be to fast track is to use already what is existing out there in other geographies. We don't have to reinvent the wheel here. We can absolutely harmonize with what is already existing, and the international standards exist. So I think that would be the easiest and the quickest way to move forward in this matter.
Yeah, so, and reinventing the wheel, don't reinvent the wheel, is very important in that point. It's not necessary. And then from Hans Bolt, there's another remark more, or it's more remark that please note there are some other issues with further increasing efficiency requirements on acts, e.g. related to the test methods.
Yeah. So the test method is for air conditioners being discussed, because there are certain things that make it difficult to assess the energy efficiency of the air conditioner. So that is indeed one difficulty, one hurdle for increasing the MEPS of ACs.
Okay. Yeah, so I'm also having a look again, and seems there are no further questions at the moment on this point. That's the reason why we have now maybe the opportunity also, first of all, for thanking again Helene for her presentation, in particular on this interesting topic, and maybe to open also the session more for more general questions or discussions, in particular, of course, to our presenters. But also, if you have more general remarks in that context of heating and cooling we discussed today, this would be now the time, of course, that you could also raise additional questions or remarks. If so, then please enter it in the chat now. So that's your opportunity to have it now. For the time, maybe you're thinking on already, if there's some remaining questions. Rather some agenda announcements, also how it will continue with particular panel 9 in the next days. And in particular for today, that was the first and starting panel. But of course, there will be more on appliances and related topics tomorrow, beginning from tomorrow on, with 2 sessions on product regulations and market surveillance and monitoring, which could also, of course, fit very well to what we heard today. And in a second session on product regulation, which will cover evaluating effects. So both are tomorrow in the evening from 12:30 p.m. in standard European summertime, Central European summertime. And yeah, looking forward to see you also there again. And yeah, after having made this announcement and which of advertisement, I'm having also a look again at the chat area. I don't see any further general questions to our presenters at the moment. So every question was already answered from very good presentations. Then I can only say thank you very much to all of you, all of our presenters. Of course, we're happy to meet you again also in the further sessions. And of course, I think we can encourage all the audience to have a look also at your papers, which also are great in covering the topics more in detail. And yeah, then thanks again. It was very interesting, and maybe see you tomorrow again, and hopefully stay tuned in panel 9. And thanks again for watching, and see you tomorrow. Bye bye.
Thank you so much.
Thank you. Bye.
Bye.
Bye. Thank you. Bye bye.